Well, hi. It's great to see people here at a conference again, sort of. I'm Aaron Margosis, Global Techno Ninja at Tanium, and I'm here to talk about Autoruns today, the Autoruns tool in the Sysinternals suite. Yes, this is the book I co-authored, Troubleshooting with the Windows Sysinternals Tools. The reason this book exists is because I needed it. I needed it to exist. I've been a Sysinternals user since Sysinternals was NT-internals back in the mid-90s and continued to use it through 21 years at Microsoft. And even today at Tanium, I use the Sysinternals tools all the time, and I needed a good reference book. Mark wanted the book to exist, but he did not have the time to write it entirely on his own. He needed a co-author. I stepped up, and I still refer to the book all the time. And by the way, it makes a great gift. The Sysinternals book, the Troubleshooting with Windows Sysinternals, it starts out with some Windows core concepts and getting started and things like that. It goes into, has chapters about all the major tools, Process Explorer, Autoruns, Process Monitor, and ProcDump, and then has chapters about all the other tools. There's about 78 tools. Last I counted, 78 separate tools in the Sysinternals suite, not counting the native 64-bit versions and the ARM versions. So the book goes into great depth about all of them and helps you make use of them, helps me make use of them. In the back then, we've got Troubleshooting, Case of the Unexplained, named after Mark's popular troubleshooting sessions at TechEd and other events. And here we show how the Sysinternals tools are used in actual real-world troubleshooting and problem-solving scenarios. One of my favorite chapters in the whole thing is Windows core concepts. This is where we just talk about things that are relevant to Sysinternals tools users, and as far as I know, was probably the first and maybe only time that app containers was ever properly publicly documented. So I highly recommend this book. So today we're going to talk about Autoruns. Autoruns is the best tool that I'm aware of for identifying auto start extensibility points, ASEPs, ASEP. Auto start extensibility points are places in Windows that are configured to automatically run code when you do certain things like start up the computer, services and drivers load. When you log in, things are hooked into Explorer, or formerly Internet Explorer as well. Scheduled tasks automatically run on your behalf when you log in, when there's idle time, etc. What are all these things? Now, a lot of them are very useful for Windows, and Windows makes tremendous use of these auto start extensibility points. So does malware. Anything powerful enough to be used by anybody is also going to be used by malware. Autoruns is a great tool for finding that stuff and removing it. And also some of the unnecessary junk that gets installed on computers. We won't name names or anything, but removing that, identifying what they are and how to remove them or where to remove them from is a great use case for Autoruns. By the way, the book does talk about Stuxnet. So here's a screenshot from when Stuxnet was still this in the middle of being discovered, and Autoruns was used to do a before and after with Autoruns, take a snapshot of here's the state of the computer now, plug in the USB, do a refresh, do a compare, and see like, these two kernel mode drivers got added to the system, signed by a legitimate code signing certificate. So Autoruns helped diagnose and troubleshoot Stuxnet. Didn't help the Iranian nuclear program much, but there it is. It also has a command line version that can be used to enumerate all the auto start extensibility points through a console so you can output to a file, including to tab delimited text, which you type into the clipboard, and then you can paste it and write it into Excel and do sorting and all kinds of sorting and filtering and all kinds of useful things like that. All right, so enough of the PowerPoint. Let's just go in and have a look at Autoruns in action. So here's Autoruns. When you start up Autoruns, the first thing it does is enumerate a ton of auto start extensibility points on the system. and displays them categorized. So we have here things that happen at logon. We have things that hook into Windows Explorer or File Explorer as they renamed it, all in one view. We can look at specific categories by clicking on these other tabs, such as logon. These are things that happen at the time of logon. Scheduled tasks that are configured, codecs that are configured on the system, etc. For each item, we have either a registry icon indicating this is configured in the registry, or a file system icon indicating that it's configured in the file system, such as shortcut files. For each of those, it'll say here is where it is configured. So this is the very popular run key, and the items inside the run key representing the AutoStart extensibility items for the run key for the current user. For each of those, it gives a name, typically from the registry value name, description, often from the file, the target file, whether it is signed and by whom, and whether that is verified or if there's a problem with the digital signature, and the target file that is being executed, as well as its timestamp. We'll talk about timestamps because those can be interesting. There can be lots of different types of timestamps. So for each of these, if we click on one of these items, in the lower pane, we can see additional information, the size of the file, the version number, and the complete command line that is invoked when that AutoStart extensibility point is started. Additional things we can do are to, if we see something that we want to get rid of, that we think this doesn't belong here, we can select an item and delete it. However, if you delete it, there's no undo. So another option instead is to temporarily disable something, just uncheck it. If it's in a per user location, all you need to be doing is running as that user. If it's in a machine-wide location, such as HKey local machine, Autoruns needs to be running with administrative rights. So before we do that, let's have a look at some other things here. So if we're interested in actually seeing this location on the system, we can right-click this group here and click Jump to Entry. It'll open up the registry editor and take us to that location and select the key. In this case, if I had selected a specific item and did Jump to Entry, it would actually select the value that was running there. Now, as I said, if I disable this item like that, in this particular case, how do you disable something in the run key? Well, let's go see when I uncheck that, what that actually did in the registry. Refresh the view here, and we see it's no longer there, but that a new Autoruns disabled key has been created underneath it. This Autoruns disabled key, Windows doesn't know anything about it, Explorer doesn't know anything about it, so it just gets ignored, but this is a place where we can stuff the items that have been disabled so that we can, if we want to, restore them simply by checking the box again. So I check that box, go back to the registry, have a look. We'll see Autoruns disabled is now empty, and the value has been restored. Now, I can also delete this item completely, and now Zoomit is no longer configured to auto-run on this computer. However, note that it does not stop Zoomit from running if it's already running. In fact, it's right here, and I can restore that value simply by going in and checking that box again. If I refresh, we see it show up again. This is, by the way, something interesting that you should watch for when you are troubleshooting malware. If you find yourself deleting an AutoStart entry point like this, and it comes back, you do a refresh and it comes back, that means typically whatever it is that AutoStart is for is monitoring what you're doing and is making sure, no, you will not delete me. So that's where you need to go find the actual running processes and go take care of them. So additional value that we can get out of Autoruns. For one thing, like I said, Windows makes a lot of use of auto extensibility points, auto start extensibility points. Here is what hooks into Windows Explorer. And you can see a lot of these things are signed with a Microsoft Windows code signing certificate. Similarly, for services and drivers, lots and lots of things signed by Microsoft. Typically, things that are part of Windows are not the things you're looking for. And so by default, actually, Windows entries are hidden by default. And if I click that, we see that this goes way, way down. We see here a couple of Windows items. It says it's from Microsoft Corporation, but it's showing up in pink because this thing has not been verified. It's not, the digital signature did not validate. We'll come back to that in a moment. But we see here far fewer things hooked into Explorer, and we can further reduce things. If you want to trust everything signed by Microsoft, we can hide those as well, hide Microsoft entries. And on this particular machine, there's nothing hooked in besides Microsoft items. Let's go back over to drivers and applying that same filter. This is from Microsoft, or it says it's from Microsoft, but the signature did not validate. So what could be up with that? Well, maybe it is malware. It's not uncommon for malware to claim to be from Microsoft and put in the version resource Microsoft, Microsoft Windows, etc. So maybe this is bad. How do we know? Well, another thing we can do, right-click the entry. Let's do this one here. Right-click, and let's check VirusTotal. So VirusTotal is an online service that has dozens and dozens of antivirus engines on it, and you can upload files to be scanned or the hashes of the files and say, have you seen this before? Now, this is an external service, and so you must separately agree to VirusTotal's terms of service. So I'll click yes here, and it will submit the hash of this file up to VirusTotal, and we get here 0 of 73. And what that means is there are 73 anti-malware engines on VirusTotal that analyze this file or a file with the same hash, and none of them said that this was malicious. So we've got this unsigned driver file that nobody says is malicious. This is interesting. We click on the link. This is a hyperlink. And we can go here and we can see, yes, here are all the engines that looked at it. All of them said nothing wrong here. Click on details, says it's not signed. Well, that's weird. This always happens during demos. The problem here is this is most likely a legitimate system file signed by Microsoft. Now, the thing about signatures in Windows is most files, pretty much all the files in Windows are signed. However, very few of them have the signature embedded in the file. They're typically in separate catalog files. So let's jump to the image. And you see here, here's a bunch of other files. And let's take one that we know is signed. Let's have a look at this one. And we're going to use SigCheck for this just to validate what I'm about to say about it. We'll use the -I option and BTAMPM sys. Okay, this is signed. And you see here, this is catalog signed. The signature is not in the driver file itself. It's in this separate catalog file. And what happens from time to time is the catalogs and the files they're associated with get out of sync. And so signature validation fails, even though it is a legitimate file and has not been modified since Microsoft published it. This happens from time to time. I've seen it happen on a number of my machines very recently. So VirusTotal is a very useful way to double check things. You can also use VirusTotal to obviously look for actual malware. If I had some malware on this system, typically it would show a number greater than 0. And if I wanted to look only for those items, I could hide VirusTotal clean entries. Let me do one other thing here. I've only done these VirusTotal checks one at a time, but I could go, let's show everything again. And we have this additional scan option. Let's check VirusTotal by default for everything. And what it'll do is it'll submit the hashes of all these files and ask, is there anything up there just based on the file hash? There is a separate checkbox for submit unknown images. If what'll happen here is, let's do that filter again, hide VirusTotal clean entries. So everything with a 0 is going to be hidden. And you'll see here that there's a few with like 1. So work folders shell.dll, there's an entry. But here you can use this to filter everything that VirusTotal says is perfectly fine. Click on this. Typically, you'll find when it's just 1 or 2, it's typically a false positive. Let me see, are there any unknowns? If there's, yes, nope. Okay, it's still submitting. It's submitting these one at a time, and there are a lot of files here to upload. In some cases, you may have something on the system that VirusTotal has never seen before, and it'll say unknown, and it will show if that's not considered a clean entry. It's not necessarily malicious, but in that case, the only way to get it checked is to do submit unknown images and submit that up. You may or may not want to do that because it might be that by doing so, you may be the victim of a very targeted attack. And if you submit an unknown image, if your system is the only machine, yours and the attackers are the only machine where it exists, if its hash suddenly appears on VirusTotal, the attacker can also check VirusTotal and can see, oh, they've submitted to VirusTotal. They may be suspicious. We need to take action now. So let me show an additional cool feature here. Okay, so I commented before about that Stuxnet thing and setting a baseline, comparing against a baseline. You can, with Autoruns, you get your collection of AutoStart extensibility information, and you can save that file, save it as a file. You have two choices. You can save it as a text file or as a native binary Autoruns file, the star.arn, which captures all the information in a binary form. You can now take this file and send it to someone else. They can look at it on their system. They can open the file with Autoruns on their system and see all the information about the AutoStarts on your computer. Another thing you can do is use this as a baseline, come back and compare later. So I've done this. Let me go in and make some changes to AutoStart extensibility points. I'm going to uncheck zoom it, so I will turn off its ASEP. And I'll go into Process Explorer and turn on Run at Logon. This configures a scheduled task for Process Explorer. I'll do a refresh. We saw zoom it disappear, but now let's do File, Compare, and compare against the baseline we captured earlier. And we can see items highlighted in red are things that have been removed since we captured the baseline. Things in green are things that have been added. So here we see this Process Explorer ASEP added and the Zoom It one removed. The next thing I want to talk about is the command line version. So you saw the screenshots earlier, and you saw these command lines. So this is what I've done. Run Autoruns. Here, let me show the command line first. Oops, no, that's not the command line. That actually enumerates all the logon entries. Here's the command line syntax. So -A, and you tell it what you want, which auto starts you want to have a look at. Star for all. If you don't specify anything, it'll look just at the logon startups. You can specify that you want to look just at scheduled tasks, WMI entries, etc. You can output as, by default, you get that table view that you just saw, or you can print it out as comma separated values, -CT for tab delimited values. I use this all the time because you get tab delimited text, it pastes into Excel just like that, just magically. H if you want to get the file hashes, S for verified digital signatures. You can also capture VirusTotal information as well if you want. You can specify just get this particular user account. And what I end up with is I paste it into Excel and format it nicely, and I get all this information. Then I can easily go in and filter and see, like, okay, what is it that I'm interested in? What is not verified? What is blank? Okay, and you can now go through and find the things that are of interest. And here are the drivers we saw earlier. One thing I want to point out, because there are some differences in timestamps, and I did want to talk about that. So here you see timestamps, and they are all over the place. You've got some in 2017, 2018, 2021, and you've got some in 2037, and you've got some in 1902. That doesn't make any sense. What was built in 1902? Well, these appear to be Windows drivers. So what I was going to say about timestamps is there are basically three different types of timestamps. There's the ones in the file system. So NTFS will tell you this is the time that the file was created, when it was last modified, when it was last accessed. You also have signature timestamps. If a file's been signed, typically there will be a timestamp associated with that signature. Now, the file system ones are really easy to falsify. I mean, if you copy it from one system to another, you can lose the timestamps. And so they don't really tell you anything. They are really part of the directory of the file system rather than of the file itself. The signature timestamp, if the signature is validated and timestamped, that's going to be a lot more reliable. This is the time at which the file was signed. Finally, you have this thing called linker timestamps. This is built into the file itself with portable executable files in Windows. So that's EXEs, DLLs, drivers, and so forth. When the build tools build the file, the linker will put in a timestamp, or it's supposed to put in a timestamp in this particular field in the PE header, the portable executable header. And it would be right here in the header. And that gets translated into a date and time. If the file's been digitally signed, you can't modify that without breaking the signature. If it's not been signed, it's fairly easy to falsify that value. But it is often reliable enough that it can tell you this is when the file was built. However, that breaks in Windows recently because starting around, I think, Windows 10, so around 2015, the Windows engineers decided they wanted to have something called reproducible builds, which is to say, if you have two machines configured exactly the same, with the same build tools, the same source code, the same configuration information, and you build the same source code on both machines, you want both of those outputs to be, of the compiled executable, to be bit for bit exactly the same. And then if you go back and build it again on both machines, you want those also to be exactly the same. Now, if the executable file is going to have a timestamp baked into it of when it was built, you are pretty much guaranteed that those files will never be the same. And Windows engineers wanted to have reproducible builds so that they could have this consistency that the files would always be the same given the same inputs. So that meant that the timestamp field had to be no longer a timestamp. And so if you use a tool like dump bin, or look into the PE headers and dig in far enough, you will find the flag that indicates that this is a reproducible build. Now, a lot of tools don't look for this, and Sysinternals or at least Autoruns and Autoruns C by default don't do that right now. So depending on the context, the timestamp you see could be any one of these things: file system timestamps, signature timestamps, or linker timestamps. In the case of Autoruns C output, these timestamps are the linker timestamps for portable executable files, regardless of whether the timestamp field actually is a valid timestamp or not. So running low on time, there's so much more to cover. A lot of it's in the book. A lot of the Case the Unexplained items use Autoruns. I recommend you get the book. I recommend Autoruns as well. It's a great tool. I've been using it since Mark first published it, and you should do the same. Thank you very much for your time.